Here's looking at you, Earth. With a plethora of new Earth observation assets being commissioned across the Pacific, including Array Labs' valuation after their Series A, 2026 has already started off hungry for a brown bag launch.
And to keep them fed and happy, we'll need to fire rockets on all cylinders, rotate their detonations, and do so from more launch sites with more launch providers all over the world.
Once we're up there, we're not leaving. Space infrastructure has had a huge week with announcements and funding for in-space manufacturing, assembly, habitats, and more.
Welcome to this week's episode of Space Times Podcast. As always, I'm Harrison Lambert.
Here with Paul Mayer.
Excited to share this week's space industry updates with you. We hope you enjoy this week's episode. Drop us a comment, check out our socials, and please follow us on Spotify, Apple Podcasts, or wherever you're receiving this signal.
Picking up on our intro, Array Labs successfully closed their Series A raise. It was a $20 million raise to scale production of their radar satellites for 3D Earth mapping, primarily focused on SAR imagery and the data insights that they're able to provide. They are in the process of mass producing some really impressive synthetic aperture radar hardware tech stacks and deploying their formation flying constellation technology on orbit. So they're friends of the show. They've successfully raised their Series A, and we're excited to try and get them onto the show later in the year here. But making great progress. Huge congratulations to them.
Yeah, this is a really unique kind of radar technology. I mean, we've been seeing so much radar recently. We've got ground radar with the LRDR. We've got space radar with Odin. This is more of a synthetic aperture radar like we've been talking about with ISI. And there's not that many synthetic aperture radar companies in the US. I think Umbra is kind of the other big one. So it's great to see another company kind of coming at this from a unique standpoint. You know, 3D maps are very valuable. We've seen that with Vantor and their partnership with Radiant Solutions and MDA Space's RadarSat. So hopefully there's some value here, which is suggested by the fact that they were able to raise so much for their Series A.
Yeah, there's one of the trends in hardware companies is, and across industries more broadly, is that for the most part, hardware trends towards commoditization over time. And so Array Labs has some proprietary technology that definitely represents a sizable technology moat in that vein. So really great stuff out of them. We'd love to see it. Elsewhere in the Pacific, the Japanese Ministry of Defense has selected 7 companies via public tender for a satellite constellation project intended to ensure stable acquisition of imagery supporting standoff defense capabilities. So these companies are all Japanese companies, and they are as follows: Sky Perfect JSAT, Mitsubishi Electric, Mitsui and Company, Synspective, IQPS, Axel Space, and Mitsui Bussan Aerospace. The contract in total is roughly 1.8 billion US dollars, 282 billion yen, and is expected to run through 2030, 2031. So a sizable 5 or 6 year roadmap there for a roughly $2 billion contract in total. Massive investment out of Japan. Huge boon for the companies down selected.
Well, and one of those is Synspective. So you've got another synthetic aperture radar company here in the mix. And I find the mix of companies interesting. This seems to be kind of like an MDA shield for Japan. Standoff defense capabilities being for like cruise missiles and missile tracking. So the fact that they've got some communication companies in here, some Earth observation companies in here, it seems to really support the fact that they are spending a lot of money building up their own sovereign capability of observing their domain, which we saw last week with when we were talking about the Mitsubishi failure on the H3 rocket. So this is just another effort by them spending a lot of money to build up their own capabilities.
And it's very consistent with the trend that we've seen globally of a big push for sovereign capabilities and being able to vertically stand everything up oneself. Additionally, elsewhere in the Pacific, EarthEye Space has announced a contract to supply satellite imagery to an undisclosed customer. They're citing access to hundreds of satellites with resolution, quote, as sharp as 15 centimeter, which is wildly impressive. I mean, we could talk for a good runway about what that actually entails.
It's like too impressive.
It's raising some flags for sure. The industry standard is 25 to 30 centimeters per pixel, right?
Yeah, I mean, 30 centimeters across like Worldview Legion, Worldview 3, Black Sky version 3, Planets Pelican, like 30 centimeters is pretty much the state of the art. Even with Albedo, which was like the lowest flying Earth observation satellite that I haven't heard whether they were successful or not, it got down to around 25 centimeters. So 15 is kind of suspicious.
So some of Earth Eye Space's secret sauce is probably related to the fact that they're also incorporating some drone imagery into their database. So they're able to uh, take satellite imagery, overlay that with potentially drone imagery, and sort of revamp and improve the resolution by doing so. But most interestingly, Earth Eye Space doesn't actually build or own any satellites themselves. They're effectively a secondary market where folks can buy satellite capacity for assets that are already on orbit. And so what I find most interesting about Earth Eye Space is not their business model or tech stack, but the role that they fill in the market more broadly, in the sense that the automotive industry is driven by secondary sales. And so we would likely expect to see that same trend follow in the aerospace and satellite industry, with that industry being driven largely by sort of secondary offers and secondary sales in this capacity. I think it's more likely that people would look to just buy the capacity than look to buy the actual assets themselves secondhand.
Yeah, and if they're integrating some sort of hybrid system between space and air, there's obviously some value to be added there. I think the closest analog we've seen recently was the visual positioning system that Vantor and Niantic came up with. But this certainly has some value add if they can incorporate two different domains like that. And yeah, like you said, being able to resample satellite imagery off of higher resolution air-based imagery is, that's possible. That would make sense if they're claiming that level of resolution.
Well, it's one potential solution for that. Finally, with regards to Earth observation, jumping back to the East Coast, back to the Atlantic here. So Satellogic has announced a cryptic 7-figure continuous site monitoring agreement with a strategic customer. The customer is nameless and has not been disclosed in any capacity.
Also cryptic.
it comes off the back of several, roughly $30 to $40 million in awards that Satellogic got throughout 2025 that focus pretty specifically and explicitly on providing low latency imagery and data insights to their customers. And what I found most interesting about this was that the tech stack and the various contract awards that they've received over 2025 represent more or less an end-to-end demonstration and solution of the primary value add that was expressed at GeoIT by members of the defense community. That need being, we want persistent imagery in real time, or as close to it as we can get. So Satellogic is not claiming to provide real-time imagery, but they are providing sort of daily updates, quote unquote persistence, recurring daily updates of the sites that need to be monitored. And those images that they're providing are not going to have the 36 or 72 hour delay that we see sort of typically in the incumbent industry timeline there. But those cycle times, if they'll be getting you today's picture today, is sort of the timeline that they're promoting there, which effectively that basically end to end sort of proves out that, hey, we can provide timely, actionable intelligence for defense purposes in conflict zones or areas of interest as needed, which I'm not sure whether or not this customer, who's unnamed, represents a defense or a national security customer. I would not at all be surprised to see Satellogic close some sizable defense contracts off the backs of these sort of contract demonstrations of that capability.
Yeah, I'm expecting them to come out with another announcement that says their customer rhymes with USA. So another news for the US, we have space infrastructure news. The biggest piece of space infrastructure being the ISS. And unfortunately for that team this week, they had their first ever instance of having to evacuate a crew from the ISS due to a medical emergency. This is undisclosed medical emergency, which is pretty common with ISS, NASA. They don't always give these kind of details, but it is notable that they pulled 4 members off of the ISS. You don't want to send a sick person down alone, so they had to pull the whole crew. That leaves just 3 people on board the ISS, which I think is the lowest level it's been at. I mean, if they haven't pulled, maybe since the construction or like the first crew up. So that leaves 2 cosmonauts and 1 American on board the ISS. Hopefully they can hold down the fort and before they get another crew up there. And we hope for the best for the injured crewmate, and hopefully they recover from their return and from their illness quickly.
Yeah, I mean, as somebody who has, every time the call goes out, submitted an application to be an astronaut with NASA, the value placed on medical doctors and medical professionals has only increased over time. And you can see why here, that the value of having a flight doctor and having somebody there who can diagnose and address and keep on top of medical emergencies to make sure everybody remains safe and healthy is, thankfully, this is the first time we're seeing that proven out to this capacity. But makes perfect sense that we want more doctors.
Yeah. The other large piece of space infrastructure currently deployed is the mega constellation known as Starlink. We've talked about this all the time, well, like every week at this point. There are about 9,000 Starlink satellites currently in orbit. They're planning to launch another 15,000 for Gen 3. But just with the 9,000 in orbit, that's approximately 2/3 of the total space objects in space. And quite expectedly, that means they have to do a lot of maneuvers to avoid those other objects. Not quite as many as I thought would happen, or more than I thought would happen, at 148,696 avoidance maneuvers over the 6 months from June to November. So we're talking about this week because the report came out announcing these avoidance maneuvers. And I think it really highlights some of what we've been talking about recently with space domain awareness, is that we are not necessarily getting lucky. A lot of the people that say we're fine, keep launching stuff, is like, oh, the chance of hitting something is so low. And while statistically that's true, it's also important to take into account that 2/3 of the objects in space are actively avoiding those collisions. And the FCC just this week approved a second tranche of 7,500 Starlink Gen 2 satellites. So this isn't even the 15,000 for Gen 3, but this will expand the current size of SpaceX's constellation by almost a factor of 2. So unless the lowering of those 4,400 satellites to not VLEO, very low Earth orbit helps, I would expect this number to only rise as they add more satellites to space. So I bring this number into the conversation to really highlight the point that all this conversation, all this technology announcements we're hearing about SDA is really needed. There needs to be an improvement in how we organize satellites, because there are other mega constellations going up. China's got 13,000 satellites going up. AST Space Mobile just started launching theirs. They've got a few hundred satellites going up. OneWeb's doing another round. They've got a few hundred satellites. So space is going to keep getting more crowded. And this really emphasizes that there needs to be an effort to improve how we avoid collisions.
Yeah, if we've got 15,000 assets on orbit currently, and 9,000 of them are actively executing evasive maneuvers once every quarter, we would expect that number to grow more than linearly as the total number of assets on there increases. And I think by the end of the decade, we're expecting closer to 100,000, 70 or 100,000 total assets on orbit. So like the sheer need for domain awareness and maneuverability is only going to increase, and the risk of collision or failure is going to increase with that.
Yeah, and some of those satellites that are going up aren't the traditional Earth observation satellites. We're getting a lot of new space infrastructure, which is very exciting. A topic that we keep bringing up, and that we had an exciting conversation last week with Space Phoenix CEO Andrew Parlick, is in-space manufacturing. One of the players that's been very active in this space is a customer rather than one of the providers, United Semiconductors. They announced a collaboration with Aegis Aerospace Incorporated on a new in-space manufacturing facility to produce essential, as the name would suggest, semiconductor materials. United Semiconductors has a lot of partnerships already in place. They have They have a partnership with five contracts for Varda. One contract with Space Forge. Space Phoenix said that they had a partnership with them as well for logistics. So United Semiconductor seems to be one of the closest to production customers for the in-space manufacturing market. This is very exciting to see that they're kind of supporting this developing technology, and we wish them best of luck with Aegis.
Regarding United Semiconductors, they're collaborating with Aegis Aerospace, but they're also collaborating with everybody else who's playing in the space manufacturing market. What this signals about the industry is that United Semiconductors either is super agnostic as to how their needs get met. They are not at all what one would consider to be a sticky customer. So either they're completely ambivalent, they view the product offerings as completely commoditized. However they're able to get the product offerings, great, we'll take it, we don't care. That's one way, one potential signal that they're sending. The other signal that they could potentially be sending here, and this is the one that I actually think is a more meaningful signal and is more likely, is that they don't view the space as winner take all. They don't view that sector or that industry or market as one in which one person is going to end up dominating the entirety of the space. They likely view this as an industry with a plurality of different players, and so wanting to have relationships and wanting to have different avenues to capacity and on-orbit manufacturing is going to be one of the best ways to do that. And so they're building relationships with everybody who's currently doing this in the space. And if there were other companies that were currently pursuing and providing on-orbit manufacturing at any level of scale, I'd be hard pressed to believe that United Semiconductors wouldn't also be trying to partner with them just to try and get as much capacity as possible. Similar to launch, there's very much going to be a capacity bottleneck for on-orbit manufacturing at scale. And so being one of the earlier adopters is absolutely going to get you preference for the capacity as it starts to scale and open up. And so that's more the signal that United Semiconductors is sending here, in my opinion, is much more so that, like, hey, we think this is real. We think this is important. We want to be one of the first adopters. We want to be one of the first people to capitalize on this as possible.
Yeah, I think it does emphasize that semiconductors are one of the highest value adds from in-space manufacturing, which sort of aligns with all the talk about on-orbit data centers and, even on the Earth, how important data centers are and the bottleneck we have on producing GPUs and CPUs.
Well, I'm sure we'll get to talk about data centers shortly.
Do we have one this week?
I think we do. Isn't that Lone Star?
Oh, yeah.
Yeah. So we'll talk about Lone Star when we get there.
Arrakis T1 D-Cubed-1 mission was manifested by Exolaunch. They'll fly on Falcon 9 on January 11th, marking Arrakis' first on-orbit demonstration of manufacturing a structure directly in free space. They are joined by a cluster of 13 Hawkeye 360 satellites, which is a maritime tracking RF kind of satellite constellation that we've talked about recently with their large funding raise last month. So they're launching Hawk 13A, 13B, and 13C, joining this launch, which is dubbed the Twilight mission, going into a fairly uncommon dusk-dawn orbit, which to me is a little unclear why they want this. It's basically skating along the sun terminator line of the orbit, which is usually valuable for Earth observation because it makes sure that you've always got sunlight, but I guess it also kind of cuts your visible section of Earth in half. So, one of the less popular orbits, but unique for this group of customers. The Arrakis orbit demonstration, like I said, is manufacturing a structure in space. This is something that Space Phoenix brought up last week for in-space manufacturing. In terms of creating large labs and production spaces on orbit, it's very valuable. It's very valuable for pretty much everything that's being considered for the next kind of era of space habitation. So space habitats, in-space manufacturing, on-orbit data centers, these all benefit hugely from the capabilities of doing on-orbit assembly. On kind of the flip side of that, we've got maybe on-orbit disassembly. There are some satellites that like to go up to other satellites and take them apart. We typically see this. Last year, we saw this with France and China and UK, America consortium in GEO, doing a lot of RPO and in orbit satellite docking as sort of a space defense offense demonstration. But now we're starting to see it show up more in the commercial sector. Last month, I believe we talked about Cosmoserve getting a partnership for their orbital grappling satellite. And this week we had Astroscale Japan get awarded a 1 billion Japanese yen contract. So that's about $6.3 million US dollars by the Ministry of Defense to develop a general gripping mechanism system designed to securely grab national satellites under a wide range of on-orbit conditions. So like I said, there's a definite defense interest to this. This seems to be more of a LEO play. So we're seeing RPO capabilities being focused on in all orbital domains. Lastly, for space infrastructure, we have Think Orbital, which announced their seed round led by TFX Capital to accelerate defense-driven space capabilities, on-orbit servicing, and in-space construction. So basically doing everything that we just talked about. This company has some interesting technology proposals, like an X-ray imager in orbit, which is very rare. I've never seen outside of the Chandra Observatory, and that wasn't for space Earth observation. It was for space observation. There were some proposals decades ago to turn it around and use it for tracking orbital debris. So I'm really excited to see a company actually attempt that with an on-orbit asset. X-rays will behave similarly to radar in that they can capture more detail about spacecraft, but with the way they're talking, it sounds like they're trying to get more detail out of the spacecraft itself, which when we look at some of the images that Vantor is able to capture from one spacecraft to another, there's definitely some value to be able to have more detail from different wavelengths captured for a spacecraft.
Yeah, so one of the value adds that Think Orbital has expressed with their tech stack is that when they are observing via RPO or not close contact RPO, but more like maybe even just mid contact RPO. But when they are observing another spacecraft with the X-ray, that you can pump enough energy into the X-ray to where you can effectively weaponize it. So there's the potential there to try and fry the electronics of a satellite that's maybe doing something that it shouldn't be doing or is somewhere that it shouldn't be by really increasing the amount of power that X-ray is using. And similarly, a lot of different satellites that we see go up are effectively black boxes. And so being able to actually see inside of the satellite via the X-ray itself at a lower power setting is also a potential value add. So Think Orbital very much sees themselves and has a lot of potential use cases in the defense and security sector of things as well. So there's also been a multitude of different updates out of the launch sector. The biggest and probably nearest and dearest to both of our hearts is the announcement that L3Harris is effectively selling what used to be Aerojet Rocketdyne. So that business branch is being sold to AE Industrial Partners, who themselves are going to be revitalizing and bringing back the Rocketdyne brand itself. So L3Harris selling $500 million stake to AE Industrial Partners. It's 60% ownership in the business unit that was previously Aerojet Rocketdyne. That puts the total enterprise value of that business at roughly $850 million US dollars. So it includes the RL-10 engine, which is a workhorse for the Vulcan. It does not include anything for the RL-25 engine or system, which is part of SLS. But this ties in with the next big announcement that we have, L3Harris selling off their RL-10 Vulcan engine component, with SpaceX sweeping the 9 security missions for SDA and NRO under the NSSL Phase 3. So 9 launches, $739 million, SpaceX clean sweep. Last year, SpaceX won 7 of the 9, I believe. Vulcan engines were able to grab 2 of them. This year, that pendulum is moving in the wrong way for the Vulcan. So L3Harris selling off effectively their investment in the Vulcan engine makes sense, given that unfortunate news for them. And
yeah, also makes sense why Tory Bruno left. Although that was a little before this, maybe he knew.
well, I'd be surprised if he didn't have, even before contracts are announced. I'd be surprised if
he
Tory
knew which way the wind was blowing.
if he couldn't, if he couldn't stick his thumb in the air and get a sense of where it was blowing. Yeah.
Well, maybe he'll have better luck with the new Glenn. They weren't under the NSSL contract, but I would be very surprised if they didn't pursue it.
I feel similarly. I think Tory is going to experience some definite success on the new Glenn with Blue Origin. Back to the Pacific. So land space, we spoke about this briefly earlier, but land space has secured formal contracts to launch satellites for China's two major mega constellation projects. So 13,000 Guowang satellites will be going up. They're going up at a rate of about a dozen satellites per launch vehicle, and only I think this would be 13. Roughly a dozen launches have put those up. So there's 136 satellites that are currently on orbit. They're going up a dozen at a time on Long March rockets, and that leaves us about 1,000 launches left. We've still got a whole bunch of launch need and launch capacity there. So land space has basically secured that.
And this is huge. Yeah, this is huge for them because they went public last week, or they got approval to go public last week. So they'll be on the Shanghai stock market. And now they've got a potential roster of 1,000 launches if they could get access to those. They just need to land. There's UK3. But they've already got this UK1 and 2 going, so they could start launching these as soon as possible. And this UK3 will only increase their profit margins. So they are very well positioned to just rake in money. Yeah,
they're in a good spot. I mean, 1,000 launches left, given I think China launched 90 rockets last year.
Yeah.
So that's 10 years of capacity, 10 years of launch capacity at their current rate. So we fully expect that to increase. Top of mind, I don't remember when the Guowang satellite constellation is intended to be fully satisfied on orbit. But that's another major indicator there of how much China is expecting their launch capacity to increase. That currently they're doing 100 launches a year. We've got 1,000 launches left, so 10 years of full capacity launch at their current rate. So whenever they say that this will be done, you can expect an explosion of launch capacity.
They said 2028, but that number doesn't really check out unless you're accounting for the fact that they're also working on larger heavy lift vehicles.
Right.
So they have like a Starship competitor, I think, out of the Tianlong group, but I forget which company exactly is working on that. But assuming one of those larger lift vehicles comes online, the number of launches will come down. Total number per launch should go up.
Yeah, the Long March is more of a competitor to the Falcon 9, right?
Long March has a lot of different ones. There's they've got small, medium, large lift. They've got the 8. The 8 is what's been launching the Guowang. I think it's the 12 that is supposed to be reusable, and then they have like a 10 that's for human rated flights. So it's just got a whole bunch of different configurations.
Interesting.
But it's been their workhorse for a long time. But there's a dozen different launch companies that China's been investing in that are all working in parallel to bring this technology online or to improve their launch capabilities. And it should be noted that like Guowang is only one of the 2 mega constellations. I forget what the other one is, but I think it's also around 8,000 satellites. So there's just tons of satellites they're trying to get into orbit. Lots of business for those companies, even on top of the funding that they're just getting as like grants from the government.
Lots of progress and some major wins for land space. Congratulations to them. Additionally, InnoSpace nearby has signed a multi-launch agreement with the Atlantic Spaceport Consortium, choosing Santa Maria in the Azores as its European launch base. This comes on the back of InnoSpace launching out of Brazil previously, and also securing an agreement with Southern Launch out of South Australia. So they now have agreements that provide them the ability to reach equatorial orbit to launch into equatorial and geosynchronous orbit rather than sun synchronous and polar orbits. And they've expanded their capacity and their footprint globally over the past year. So big progress for Innospace as well.
Yeah, I don't know if they'll ever reach Geo, at least not with their current lineup. The Handbit Nano is very, very small. It's like 150 kilogram launch capacity. The Handbit Mini is not much bigger. It's still a small launcher. So unless they eventually get to some sort of medium or heavy lift vehicle, they're not going to get anything meaningful up to Geo. But
that's true. The agreements are for the next 5 years.
Yeah. Well, I'm sure they'll expand. I mean, Azores hasn't even come online yet. Like, I think we talked about it a month ago. It was like the 200 million funding from ESA to develop that launch base. So, I mean, this will be one of their anchor customers. As you pointed out, like the fact that they've got launch bases now out of like Naro, South Korea. They've got the Alcantara out of Brazil. They've got the Smallbusca out of Azores. They've got the Southern Launch out of Australia. They're basically spreading their launch bases all over the world, which I think gives them a really unique flexibility between the size of their vehicle and the locations they can launch from, which is really valuable to a lot of customers. I know Space Phoenix brought it up last week as one of their key launches they're looking at, which makes sense. It helps with their cadence, their bottleneck, the logistics of moving stuff around the Earth once it comes back. And even as we were talking about with, was it Satellogic, like the fact that they want to launch into like custom orbits with their own satellites on dedicated launches, like this kind of capability is very enabling for those kind of technologies, those kind of orbit designs and all of that.
Yeah, I mean, increased diversity of solutions leads to increased resilience in capacity and capability. So good stuff to see. In some bigger business moves, so Starlab Space announced an investment from 7 grand managers, an asset management firm or a hedge fund with over $1 billion in total AUM. Starlab Space, remember, is the joint venture between Voyager Space, Mitsubishi, MDA, and Airbus. So all of the companies that are engaged in this joint venture are themselves publicly traded and are big name, well-established companies. However, Starlab Space itself is very much in the startup ecosystem. It's technology that has yet to be tested. It's a product that has yet to have sort of a closed business model. It's all very early stage stuff. So it's a very unique and I'll say off-brand, off-historical investment play for 7 grand managers. Broadly speaking, we've spoken about this previously, but broadly speaking, I remain very skeptical about the commercial business case closing for an ISS. The ISS is not a money-making effort. It is a geopolitical effort. It doesn't. There's not a way to easily commercialize that business model, and so. Yes, you can alter it and you can find ways to where there would be a way to profitably create a private or commercial successor to the ISS. However, I have not seen the customer demand for that type of product realized or materialized at all. Granted, this is an effort between Voyager, Airbus, Mitsubishi, MDA, so they would probably know about as well as I. But this, I get, without any internal or inside knowledge, without any insider baseball here, I get the impression that this is an off-brand investment and, relatively speaking, a pretty big risk for 7 grand managers. So wish everybody very well, but I don't fully understand this investment or why SGM would do so. Granted, it could be a small bet of a couple $1,000,000 here or there. It might not be something as extensive as maybe we're led to believe. And maybe they have a whole lot more information that spells out everything, and maybe I'm the one who's out of touch.
Nah, man, you're not out of touch. You might be out of time, though. I think Starlab Space is in sort of a weird position. Like it seems like very much a consortium play, which a lot of the times this just amounts to large companies trying to get their share of government contracts. Which if it seems positioned to be a commercial replacement to the ISS. So I would expect that having a partnership between the US, Japan, Canada, and Europe would kind of give them the best positioning to grab as many contracts as possible. So I could kind of see an asset management firm interested just in terms of like the money that will come into this, but they're pretty far behind and their advantage is not all that great compared to companies like Axiom and Vast. Like Vast has a head start. They're supposed to launch Haven 1 this year, which if everything goes well for them, then that gives them a huge leg up. And Axiom Space has the benefit of having Cam Ghaffarian, who seems really plugged in with the U.S. Industrial complex. So Voyager is going to have headwinds against him. Airbus, they're already kind of partnered with the exploration company that we talked about last week. So I feel like their interests are going to be kind of torn. But MDA and Mitsubishi, those are good partners. MDA worked on the robotic arm for the ISS, so they've got experience with this sort of thing. And Mitsubishi's a huge player in Japan's aerospace industry. So, certainly Starlab has a lot of potential to succeed. But as you noted, like it's a very weird industry. There's not a lot of business case for it.
Yeah, well, I mean, I just the fact that all of these companies themselves are publicly traded, like why invest in this joint venture and not just invest in the companies that own the joint venture directly, especially when your track record is of owning publicly traded equities and not owning, not necessarily investing in ventures at the early or pre-revenue stage. But
yeah.
Anyways, moving right along, wishing everybody the best. So we foreshadowed this a little bit earlier in the call, but so Lone Star Data Holdings, a company whose mission has been providing and creating lunar and on-orbit data centers, has closed a $6.5 million seed round and has named Stefan Eisel as the CEO. Founder Chris Stott is going to step into a new role as executive chair and continue Lone Star's long-term strategy and building towards the vision of lunar data centers, while Stefan Eisel is going to focus on market expansion and revenue growth in the orbital and nearer term and also nearer orbit revenue opportunities.
Yeah, this is an exciting raise for Lone Star. They're one of the furthest ahead in the orbital data center play. They're also one of the more unique takes on it. Most companies that are talking about it, like StarCloud, SpaceX, Planet, Aetherflux, like they're all talking about on-orbit compute centers, which are very power and heat intensive applications because those computers are running all the time, and your profit margins are worse because the equipment's more expensive, and all the supporting equipment's then more expensive. But Lone Star is taking on a data approach to it, which the data is not as compute intensive. You have to use some compute to read write. You've got the RF to get it down to Earth. But in the case that they're targeting specifically, it's for backup data. So it's pretty much just cold storage, which means the cost for doing it is very low. You don't really need to use it until somebody needs access to it, which hopefully is never, since it's for backup. So the business case makes a lot of sense. I think the market size that they can target is a bit smaller. I would probably say a lot smaller. But I certainly think there's enough there to make sense for this company. And I think their approach to doing this on the moon is relatively unique. A lot of people have just been talking about doing it in orbit. But I think doing it on the moon has a lot of benefits, both having like a thermal heat sink and not having to maintain space structures. It's just a little easier to manufacture and assemble stuff on the moon. And so I like to see there being kind of a diversity in approaches to how we're going to do orbital data centers.
So in addition to that, there's a couple of raises that we wanted to announce here. So CUS GNC closed a $760,000 pre-seed round. Early stage company, small raise, but satellite GNC software is still a problem. It's something that still needs to be optimized and solved for the new space economy. And so it's good to see additional entrants looking at doing so. Anybody willing to play in this space is welcome in our books. Additionally, Karman raised $5 million to expand their solid rocket motor nozzle production capacity. So this plays in with the Avio, it plays in with Lockheed Martin, it plays in with a lot of the growth that we've seen in the solid rocket motor space throughout the back half of 2025. And it doesn't look like that's going to be slowing down in any capacity in 2026.
Yeah, both point to patterns that we've been seeing a lot of. Like GNC is key for RPO technology, which is high importance for space defense and technology there. And Karman playing in that solid rocket motor space has been a very loud intention of the U.S. government to rebuild kind of the industrial base. And this is a key technology that's pretty difficult to make. So scaling out that production capacity will benefit a lot of companies that we've talked about, Avio, Ursa, Lockheed, Raytheon. So hopefully this goes a long way to expanding their capability. For some technology that doesn't fit into the general topics or any sort of business advance, we've got a few this week. Momentus having back-to-back success. First off, with the announcement of the partnership with Velo 3D to create a advanced metal additive manufacturing technology for creating fuel tanks and for their spacecraft. So this is supposed to go on the Vigoride 7 launch or service vehicle, which is already a very packed manifest. So I'm starting to wonder where they're going to fit all this, but this technology is a very interesting partnership. A lot of the other partnerships they've had are about on-orbit manufacturing and assembly, some RPO technology with sensors and robot arms. So they're just doing it all. I guess this kind of fits into the on-orbit manufacturing aspects, or it could just be a matter of different production methods for their fuel tank. But I like to think that it plays into the on-orbit manufacturing aspect because one of the key technologies for Momentus is their water-based plasma thruster, which the whole purpose of it is that you can find water in space so you can refuel your vehicle in space. It serves as a good orbital transfer vehicle for transplanetary exploration. So being able to expand your fuel tanks to add more fuel, do all of that is playing in with their key value proposition very well. On another company also announced a partnership with Momentus. Juno Aerospace got a NASA REACH grant for $2.5 million to develop their rotating detonation rocket engine, which is one of my favorite technologies to talk about. Apparently, Momentus is part of this grant, so likely see one of their demonstrations flying on that vehicle, which only expands the different applications that Momentus is proving out on their orbital transfer vehicles. But for Juno, this is exciting funding. They're a bit early, but so is pretty much any other company that's doing rotating detonation rocket engines. For those of you that don't know, since this is a pretty niche technology, a rotating detonation rocket engine is different than a traditional combustion rocket engine in that the combustion happens in bursts. So rather than just burning all your fuel, you're getting the most impact out of the explosion as possible, and it creates a more efficient rocket for you to use. This, to me, is one of the biggest technologies in development right now because it would bring up the efficiency of rocket engines. It could be one of the biggest technologies that would give a boost to the launch vehicle industry. And my hope is that this kind of leads us closer to single stage to orbit vehicles, which has always been out of reach, just given the rocket equation and the efficiency of fuel. This could give us a real leg up to get there. And there's not many companies working on it. We've talked about Venus Aerospace in the past. General Electric has a RDRE that they've proven through their kind of skunkworks program, but I think theirs is pretty dedicated to missiles. I think all of these companies will likely pursue the missile hypersonics roadmap as part of their business structure, but I really hope that this technology gets brought over into the launch vehicle side of things as well.
Yeah, before we move on here, I really just want to again take an opportunity to compliment John Rood's leadership over at Momentus. This is the second or third week in a row that Momentus has had some major wins that we're announcing on, and this is we have spoken about them frequently on our show and how much progress they've made since John Rood stepped in as CEO. So briefly, just wanted to call out and compliment his leadership over there as they're now partnering with Juno on some of the most fascinating technology in the industry.
And in other big news this week, Schmidt Sciences Philanthropy Group, led by Wendy and Eric Schmidt, announced the Lazuli Observatory being deployed by 2029. If the name Eric Schmidt sounds familiar, that's because he was the former CEO of Google and the now CEO of Relativity Space. So this is a family that's been in this industry fairly recently, but this is a totally separate effort of theirs to build out new technology through philanthropic donations. They've worked to develop other technologies before, like at CERN Laboratory, but this is very focused on space observation, which is traditionally in the domain of NASA and other government agencies, but with those budgets being cut, this is a valuable donation to continue the research that's typically done by those agencies. So the biggest of the observatories that they're funding is the Lazuli Observatory. This is meant to be larger than 3 meters, which make it larger than the Hubble, and include a planet-finding coronagraph, a high-resolution wide-field camera, and a light-splitting spectrograph, which will study the atmospheres of distant worlds and dissect the light from exploding stars and tackle mysteries such as the nature of dark energy. This is backed up by a couple of other observatories that are going to be kept on the ground, including the Deep Synoptic Array, which will study the sky at radio wavelengths, and the counterpart, the Argus Array, which will observe invisible light. There's also a third, smaller but scalable array, which will gather spectra of cosmic targets such as exoplanets and supernovae. So these are all very fascinating observatories we built out. The space industry thanks the continuing work of this foundation to keep up the good work of this observation technology. And I'll be excited to see when the Lazuli goes up to orbit how it does. Since they're comparing it to the Hubble, that's not the best omen, but I hope that it works out for the best.
Well, here's hoping that it's closer to on par with the James Webb, if not stepping up from the James Webb.
Well, that will do it for this week's recap of the space industry. We hope you enjoyed this episode of the Space Times podcast. As always, please drop us a comment, check out our socials, and follow us on Spotify, Apple Podcasts, YouTube, or wherever you're receiving this signal. Until next time, this is Harrison Lambert and Paul Mayer signing off for now.